Okay guys, in this lesson we're going to take a look at how to deal with complex numbers. So a complex number consists of a real portion and an imaginary portion. The general form is given by a plus bi, where a is the real portion and b is the imaginary portion. So we're going to talk about imaginary units or imaginary numbers. Okay, the imaginary unit I is defined as the square root of -1. So throughout Algebra 1 and all our lower level math classes, we've been told that we can't take a square root of a negative number. But we're going to learn how to deal with that right now. Okay? So I'm going to simplify the following square roots. Okay, so what I'm going to do is anytime I see square root of a negative number, I'm going to factor out an I. Okay? So this is I times square root of 2. Because I is defined as the square root of -1. Okay? And that's our answer. Okay? So square root of 4 is 2. So this would become 2i. Okay? Square root of 96. Factors of 96 are, let's see, 4 and, let's see, we're good. I think it's divisible by 16. 16 and 6. Yeah, 16 and 6. Let's do 16 and 6. Just save us some effort. If you want to do your factor tree more, you can. So factors of 16 are 4 and 4. 6 doesn't break down any further. It'll break down in 2 and 3, but you can't pull any factors. So this becomes 4i square root of 6. Next one, when we square root a fraction, we square root the top and we square root the bottom. So the square root of 25 is 5, square root of 36 is 6. So this is going to be 5i over 6, or 5/6 I. Doesn't matter how you write it. Okay? And that is how we deal with basic I questions. Now, going through, we're going to solve some equations that deal with square roots and that good stuff. Okay, so when we're dealing with square roots, we're going to always isolate the squared. Okay, to get rid of a square root, we square root. To get rid of a squared, we square root both sides. So we're square root, and we're going to square root. Now, whenever we're dealing with squareds, we always have to have plus or minus, because it always has to have two solutions. Okay, so square root of 144 is 12, so this is plus or minus 12i. Okay. So when we're dealing with squareds, it always has to come in pairs. Next one, we're going to isolate the squared, and we're going to move the 48 over to the other side. So x squared minus 48. We are going to take the square root of both sides. Like that. Now, when we take a square root, we have plus or minus. Now, 48 is going to break down into 16 and 3 and 4 and 4, right? So we can bring out the 4, so it's 4i square roots of 3 is your answer. Okay, we want to simplify those radicals. Okay, next one, we're going to move the 25 over and then divide by 9. So we get x squared is equal to a negative 25 over 9. We're going to square root both sides. When we square root, we have to have plus or minus. Square root of fraction, we're going to square root the top, then square root the bottom. So square root of 25 is 5, square root of 9 is 3. So it's 5/3 I. Like that. Okay, and that's it. Make sure you don't forget your I when you're taking square root of a negative number. Okay, so this stuff shows up on SAT, so you need to make sure that you know how to do it. Imaginary numbers occur in iterations of 4. So an iteration is just a pattern, okay? They mimic the following pattern. I to the 1 is equal to I squared is -1, I cubed is -I, and I to the 4th is equal to 1. The way I remember it is I1, the middle two are negative, okay? So let's evaluate the following without using a calculator. So I to the 27th power. So what we're going to do is we're going to do 4 divided by 27. Old school. Okay, 4 goes into 27 6 times with a remainder of 3. So the remainder tells you what it's equal to. and it's equal to a negative I, like that. That's it. 101. 4 goes into 101 25 times with a remainder of 1. Okay, so I to the 1 power is just going to be I. 84. 4 goes into 84. Okay, so 2. 21 times with a remainder of 0. So if it goes in evenly, it's going to be 1. Okay? I to the 4th, which is equal to 1. That's the only really tricky one to do. Okay, so your remainder is what your exponent's going to be. Okay? So if it's a remainder of 0, it's actually 4. Okay, it's the 4th term, is 1. Okay, now we're going to talk about something called a conjugate. So a conjugate is pretty much the same thing, but the sign in the middle changes. Okay, so we represent a conjugate by z bar. So if we want to find the conjugate for these two examples, so we're going to write z bar, and it's just going to be 3 minus 4i on this one. So the conjugate, we just change the sign in the middle. Conjugate for this one is going to be a negative 7 plus 5i. Like that. That's it. Nothing more to it. Okay, so when we perform operations, deal with complex numbers, we're going to combine our like terms like we do with normal x's and y's. You have to combine the real part with the imaginary part. Okay, you can't just put them all together and think that they're going to be the same because they're not. Okay, so we're going to deal with the real parts first. 3 plus a negative 2 is 1. 5i plus 3i is 8i. And that's it. 6 minus 3 is 3. 4i minus 6i is a negative 2i. Okay, those are pretty easy. Now, multiplication. We're going to FOIL. Okay, so 5 times 2 is 10. 5 times 7i is 35i. 3i times 2 is 6i. And 3i times 7i is 21i squared. Now, we got to put it in normal form. So that I squared, remember, if we go back to our notes, I squared is equal to a negative 1. Okay? So that's something important to remember. So it's negative 1. So 10 minus 21 is a negative 11. Plus 41i. Sure answer. Okay, so next one, we're going to square this out. 2 squared is 4. We got to square the I is 4i squared. And like we just did on the last one, I squared is equal to a negative 1. So this is a negative 4. Next one, we're going to FOIL. 2 times 1 is 2. Outer terms is minus 2i. Inner terms is I, and last term is going to be minus I squared. Okay? Remember that I squared is equal to a negative 1. So this is going to become 3 minus I when we combine our like terms. Okay, negative 2i plus I is negative I. Okay, the reason we learned this whole conjugate business is to evaluate stuff like this. And it also works when you have square roots on the bottom of a fraction, okay? So we're going to do this strategy of multiplying by a conjugate to simplify this. So the conjugate of 3 plus 4i is 3 minus 4i. So we multiply top and bottom by 3 minus 4i. That times 1 is just itself. Now, pay attention to this. So 3 plus 4i and 3 minus 4i is going to be a difference of squares. So I'm not going to bother with foiling it all out. I'm just going to multiply the first terms and the last terms. So 3 times 3 is 9. 4i minus 4i, that's minus 16i squared. Now we know that I squared is equal to a negative 1. So that comes out to be 25, like that. Okay, and if you want to split this up, you can. 3 over 25 minus 4 over 25i. Okay, the next one is worked exactly the same way. Anytime you have an imaginary unit on the bottom, we're going to multiply by the conjugate. So the conjugate of this is 5 plus 12i and 5 plus 12i. Now, we're going to have to FOIL out on top. Okay, so 1 times 5 is 5. 12i plus 20i plus 48i squared all over 5 times 5 is 25 minus 144i squared. Now we know that I squared is equal to a negative 1, so that comes out to be 169 on the bottom. We can also take this I squared right here and make that a negative 1. So 5 minus 48 is a negative 43 plus 32i all over 169. If we want to split it up, negative 43 over 169 plus 32 over 169i. Okay, so this is your real part and this is your imaginary part. Okay, last one. We're going to multiply by a conjugate. So we're going to multiply by 4 plus 3i on the bottom. 4 plus 3i on top also. We're going to FOIL out the top. So 2 times 4 is 8 plus 6i minus 12i minus 9i squared. Okay, we're going to multiply out the bottom. It's going to be a difference of squares, so 4 times 4 is 16 minus 9i squared. I squared is a negative 1, so this becomes 25 on the bottom. This I squared on top, we're going to make it a negative 1. So combining our like terms on top, you get 17 minus 6i over 25. And if you want to split it up, yeah. And that is how we deal with conjugates and imaginary numbers in a nutshell. So make sure you remember, when you take a square root of a negative number, you have to factor out an I.